Hey everyone, so today we are doing something new on a GPU. I am on the lead GPU portal. I have a bunch of GPUs that I could choose from, and I've chosen the NVIDIA Tesla T4. I am using the CUDA C++ language. So we would be doing matrix multiplication on a GPU. So we are given a matrix A of dimension m cross n and matrix B of dimension n cross k, and we need to compute the product matrix C, which will be basically A times B, and which will have dimension m cross k. Pretty standard matrix multiplication, right? And then there are some implementation constraints, and then let's look at some example. Matrix A, matrix B, the output matrix would be like this. How does the matrix multiplication work? It's pretty simple. You do, these are basically the rows and these are the columns, and you basically, simple linear algebra, and you will get this. Not going into how matrix multiplication works underneath, but yeah. So there are some constraints and then some performance constraints, how they will be measuring the performance on this platform. Now coming to the code, so how is GPU programming different from the normal CPU programming? So there is concept of threads, right? Threads basically one unit of work. There is a concept of block, there is a concept of grids. So there is like grids which have multiple blocks, and then blocks have multiple threads. So here here in a way we are defining, hey, each block will have 16 cross 16 threads, which is basically 256 threads in a block. And then we have blocks per grid, and we are computing how many blocks do we actually need for this computation. So in this case, if the output matrix, which is of dimension m cross k, would have been a large matrix, then there would be need for more blocks, because anyway we have 256 threads per block. But if we need to compute more elements in the output matrix C, then we will need some way to trigger more threads, and then to kind of store those threads we will need more blocks, because hey, each block can only contain 256 threads in this case. Okay, so now we trigger a kernel. What exactly is a kernel? Kernel is basically one unit of work. One kernel is parallel to a one single thread, so a thread will execute one single kernel. So now we need to store the output in C, and M and K are the dimensions, A, B, C are basically the matrix, A and B being the input, C being the output. What we do here is that we get, hey, which particular row and column in the output matrix C are we trying to compute in this particular kernel. So as I said, there is a concept of blocks, block dimension, block index, thread index. Using all of this, we get, hey, this particular row and this particular column are the ones that this thread would be, or thread slash kernel would be computing the result for. Now we do some boundary checks. Are we still within the constraints? So there might be some threads in some blocks which probably is not necessary to do the work. So this would be like ghost threads, and that's why, to just make sure that we are doing the right work, storing in the right way in the output matrix C, we have some constraints, checks here. Now we do some basic arithmetic. You see how is this different from the normal CPU, where we don't have multiple 3 for loops, we just have one loop to calculate one particular cell, right? So here we have a for loop which goes over a particular cell to get the actual value it should store, and then we just multiply A and B over this loop, the elements in A and B over this loop, and then finally the value that we get is stored within the output matrix C. That's about it. Simple. There are more logics that we need to be aware when we are doing the GPU programming, but that's it for today. Hope you liked it. See you soon.